Welcome, stargazers. Might you, at any moment, put your faith in it and imagine a heavenly event so large that it obscures areas on Earth, apparent even without trying to conceal that scene, which may be near us. At the very edge of Orion's vision, Betelgeuse is in the Betelgeuse constellation, acting strangely, indicating a looming cosmic explosion that will illuminate our sky more than ever. However, when will Betelgeuse go supernova, and what will it mean? According to researchers, it appears that this heavenly event could reveal secrets. Discover with us as we delve deeply into the specifics of the actual transformation of Betelgeuse and the potential effects it may have on Earth, and possibly on nearby planetary systems. Located around 650 light-years away from Earth in the Orion constellation, Betelgeuse is not just any normal star. It's a massive red supergiant, one of the brightest stars known to us, shining with a brilliance more than 100,000 times that of our Sun. But why is this red giant so significant to us? Well, Betelgeuse stands out not only for its brilliance but also for its history and importance in human culture. Named after the Arabic word Yad al-Jaz, meaning the hand of Orion, Betelgeuse has been noticed and documented by ancient civilizations for hundreds of years. It has served as a guide for travelers and a source of wonder for astronomers. Its rough, reddish color sets it apart from other stars in the Orion constellation. Can you imagine a single star casting a shadow over our entire solar system? Just to name a few examples to give perspective on the sheer immensity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star be that massive? At 10 million years old, Betelgeuse is significantly younger than our 5-billion-year-old Sunday. However, its enormous size means it burns through its material much more quickly, resulting in a much shorter life expectancy than smaller stars. Now, this celestial behemoth, traversing a volume sufficient to hold more than 1 million suns, is approaching its final cycle. When stars of such size reach their twilight years, they don't simply fade away. They leave with a cosmic explosion and extravagant flare, a blast beyond human understanding in terms of brilliance and energy. Such an event has the potential to dominate a whole galaxy by producing regions of light across vast distances. The last time a supernova this close to Earth occurred was in 1604, before the development of modern telescopes. That event, known as the Kepler supernova, was visible to the naked eye for over a year and a half, brighter than any other star in the night sky and even observable during the day for several weeks. What secrets do these heavenly remnants reveal to us? Ancient records from various civilizations, such as the Chinese, along with observations from European astronomers, document the appearance of this new star. Evidence of this blast remains today in the shape of a cloud of expanding debris, still visible with modern telescopes. It gives us insights into the violent ends of massive stars. Supernovae have been rare for observers on Earth. However, try to picture a stellar explosion so intense it rivals the brilliance of the full moon, casting shadows on Earth at night and even being visible during daylight. The radiation from such an event could charge our atmosphere, possibly affecting satellites and even the climate. Betelgeuse's unpredictable dimming patterns suggest that it might be preparing for just such a grand display. Could we be on the edge of witnessing one of the most dramatic events in the universe? Just recently, astronomers made a surprising discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable transformation that drew the attention of astronomers and skywatchers worldwide. Known as the Great Star Dimming, its brilliance, which had been stable for centuries, began to decline significantly. This sudden change was so noticeable that even casual stargazers observed it when comparing Betelgeuse to other stars. This suggests that we may not be hundreds of years away from seeing its supernova blast, but perhaps only a few decades or even less. By April 2023, according to cosmic observations, Betelgeuse had resumed its previous levels of brightness. Many believe that the anomalous period culminated in a stunning turn of events. In the months that followed, Betelgeuse's splendor intensified by an astounding 50%. Such prominent variances, while typical of variable stars, were surprising for a star like Betelgeuse, which had exhibited predictable luminosity cycles. This abrupt and significant increase in brilliance pushed it back into the spotlight, igniting discussions about its future. But what caused this sudden change? Why did Betelgeuse change its brightness? One of the most familiar stars in our sky suddenly threw us a divine curveball. Stars don't just shine. They are dynamic entities with behaviors and life cycles full of mysteries. For some celestial bodies, periodic brightness variations are expected, much like the rhythm of Earth's seasons. Throughout its stellar existence, Betelgeuse has maintained a relatively consistent 400-day brightness cycle. However, with the Great Dimming, it appeared to defy its established behavior, challenging our understanding of cosmic phenomena. Now, you may be pondering whether we are on the verge of a cosmic revelation. Though the precise reasons for Betelgeuse's abnormalities are still under investigation, a convincing hypothesis has emerged. This hypothesis focuses on stellar activity and mass ejection. It presents an intriguing scenario. Picture Betelgeuse as a massive celestial volcano, quietly releasing large quantities of its substance into space. Recent observations from the Hubble Space Telescope discovered that Betelgeuse had recently expelled a tremendous amount of surface material into the universe. This ejection, a monumental event, was 400 billion times greater than the mass typically released during similar solar phenomena, comparable to several times the mass of our Moon. Such events can result in the formation of a thick dust cloud that influences the star's apparent brightness, temporarily making it more difficult to observe. Afterward, as this dust began to disperse or was pushed away by the star's radiation pressure, the veil lifted. This could explain its subsequent return to normal levels of brightness. In one way or another, these new developments suggest that the star is far from finished, surprising many of us. It's possible that Betelgeuse is approaching its final phase of life, with a supernova event, a sudden burst of energy that could eclipse an entire galaxy. This will appear in a flash on the horizon, an extraordinary phenomenon that may occur when unexpected changes happen in the star's core. Such changes can arise if a star absorbs too much matter from a nearby companion, an adjacent star, or, in Betelgeuse's case, as a result of its exhausted nuclear fuel, overflows its mass into the core, establishing the conditions for a catastrophic collapse. But what drives a huge star like Betelgeuse to its end? Born from the gravitational collapse of gas in stars' molecular clouds, stars, just like Betelgeuse, begin their journey by consuming hydrogen in their cores. This is the initial phase of the main sequence, which lasts for billions of years and lays the groundwork for a star's life. As stars near the end of their hydrogen supply, they expand by utilizing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium. This results in the formation of oxygen and carbon. During this transition from the main sequence to the helium-burning phase, the star evolves into a red giant. Over time, as the star's helium reserves decrease, it undergoes additional changes and expands into other burning stages, each marked by the fusion of increasingly heavier elements. The larger the star, the faster these transitions occur, given the immense gravitational forces at play. The culmination occurs when iron begins to form in the core. In contrast to lighter elements, iron doesn't release energy when it fuses. The resulting energy is inadequate to counter the star's own crushing gravity. The star inflates in size before eventually collapsing and triggering a massive rebound explosion, resulting in the explosive force of a supernova. So, is Betelgeuse getting close to the edge of a catastrophic end or simply taking its time? Ongoing research by the Tohoku University in Japan suggests that the star might currently be in its carbon-burning stage. Lead scientist Hawk believes that the internal structure could collapse within a few years once its carbon reserves are exhausted. However, not everyone in the research community agrees. Studies from the Konkoly Observatory in Hungary hypothesize that Betelgeuse is still in its earlier helium-burning stage. One thing on which all scientists seem to agree, despite these debates, is that Betelgeuse is set to become the Milky Way's next supernova. But determining the timing of this event is still a huge guessing game, with bets ranging from just a few years to 100,000 years. Amid these scientific speculations and discussions, one thing about the future of Betelgeuse remains unchallenged: the very nature of our observations. When we look up at the starry field, there's a subtle paradox we often overlook. This paradox lies in the very concept of time and light. In our vast universe, stars and other celestial bodies are so distant that their light takes an immense amount of time to reach our eyes. For example, despite the impressive speed of light, 186,282 miles per second, the light from distant stars and galaxies takes years to traverse the vastness of space before it reaches us. Looking at Betelgeuse, you're actually experiencing a show from 650 years in the past. To put that in context, when this light left on its journey toward Earth, the Renaissance was merely unfolding, and adventurers like Marco Polo were making a name for themselves in history. Each and every observation we make regarding Betelgeuse is like looking through a vast time capsule, giving us glimpses into its distant past. If Betelgeuse had already burst into a brilliant supernova, we wouldn't know for another 650 years. So, while we study and predict its impending supernova, somewhere out in the vast universe, this amazing event may have already unfolded. We're simply awaiting its passage through time before it reaches our eager telescopes. Recent discoveries surrounding Betelgeuse have sparked intense conversations within the astronomy community, which is now shifting its focus to a different, shocking revelation, SN 2023X. This recently spotted supernova, which occurred in a galaxy neighboring the Milky Way, evoked many memories of the fascinating dynamics and mysterious nature of the universe. SN 2023X was discovered by millions of people from a distance of light years, showing an intense burst of brilliance that instantly outshone its host galaxy. What made it particularly interesting to researchers, as well as casual observers, was its uncanny resemblance to what many expect will be Betelgeuse's fate. The raw power and aftermath of the blast provided an enticing glimpse into the processes that these enormous stars undergo as they near the end of their life cycles. For many, SN 2023X served as a preview of what might happen when Betelgeuse meets its fiery fate. The sequence of events might look very similar to what was observed with SN 2023X. Moreover, the connection between these two celestial events underscores a larger theme about the nature of our universe's interconnectedness. Whether it's a nearby star like Betelgeuse or a distant supernova like SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the astronomical implications, such an explosion would have significant consequences for human culture. A star that was noticed and admired in the sky for centuries would vanish, prompting reflections on impermanence, the immense scales of cosmic time, and our place in the universe. Such cosmic wonders remind us of the ephemeral nature of existence and our unending quest to appreciate the majesty of the past. As we consider the potential supernova of Betelgeuse, it's essential to understand the broader effects of such an incident on our cosmic community. When Betelgeuse finally reaches its explosive end, it could affect more than just our immediate vicinity in the Milky Way. It could also influence the dynamics of the interstellar medium. The shock waves produced by the supernova will result in large areas of ionized gas, enriching the space around it with heavier elements forged during the star's life cycle. This process plays a crucial role in the grand cosmic cycle of matter, fostering the creation of new stars and planets with the essential elements for life. In addition to the light from the explosion, it could serve as a cosmic laboratory for astronomers. By studying the light curve and spectral features of the supernova, researchers could gain invaluable insights into the life and death of massive stars. Supernovae offer a unique glimpse into the physical processes at play, revealing how energy is distributed in such cataclysmic events. By studying these phenomena, scientists can refine their models of stellar evolution, contributing to our understanding of the cosmos life cycle. Beyond scientific change, a supernova could also bring about cultural repercussions. Throughout history, important cosmic events have influenced literature, philosophy, and art. The brilliant appearance and legacy of Betelgeuse would likely inspire a new era of artistic expression and reflection. People across the globe would gaze up at the night sky in contemplation of their place in the cosmos. This event could spark a renewed interest in astronomy and science, much like the curiosity that emerged during the Renaissance when celestial observations began reshaping our understanding of the universe. From a practical standpoint, the effects of a supernova could extend to technology, posing increased radiation levels and challenges for satellite communications and navigation systems. These implications would require advancements in protective and shielding technologies, extending the boundaries of space engineering. As space exploration continues, our increasing reliance on technology that comprehends and adapts to these cosmic events becomes essential for reducing their impact on our everyday lives. The supernova might also alter our perspective on time itself. Its fleeting nature serves as a reminder that even the most monumental celestial bodies are not eternal. This realization might prompt philosophical debates concerning existence and the shortness of life. The universe operates on time scales far beyond human lifespans, but we still find meaning in our brief moments under the stars.